The way the textbook does this problem, in my opinion, is not the best way to attack finding the real solutions of x cubed plus 5 equals 4x squared plus x. The way the book does it is they put one side of the equation in y1 equals and one side of the equation in y2 equals, and then it graphs it and finds the point of intersection of the two graphs. Now, this is actually a fine method, except for the fact that there are 3 solutions to this system, and one of them cannot be found without you adjusting the window. But what if you didn't know to adjust the window? Well, the way I recommend doing this problem, so that you never get it wrong, is to get the equation equal to 0 by subtracting the 4x squared, subtracting the x. Remember, it doesn't matter what order you write this in, because when you type it in the calculator, it will still find the right answer for you. Then go put this in y1 equals, put 0 in y2 equals, and you'll see this. Now this is much easier to find the 3 solutions. Now I realize you're looking at it and you're going probably, oh, it hits at -1 and 1 and 4. But just because it looks like that, it can be deceiving. What I want you to do is instead go and use the intersect function. As long as you put the equation y1 equals and you put 0 in y2 equals. Then go and find where it hits the x-axis by doing the second trace, 5, enter, enter, enter. When I do this the first time, it gives me this, it gives me this point, which is 1.16. When I go and do second trace, 5 again, I'm going to now move my cursor close to this 0, so before I hit enter 3 times, so that it tells me the answer is -1.09. And now I'm going to do intersection one more time to find that 0. Before I hit enter 3 times, I'm going to make sure the cursor is close to that 0, and it tells me the solution is at 3.93. And those are the 3 real zeros of the equation x cubed plus 5 is equal to 4x squared plus x. Again, I did this different from the book because if you do it the way the book does it, you will only see 2 of the solutions and not really know that there's a third solution without changing the window. This way, you don't have to change the window. You can see all 3 solutions right there on your screen. Remember, just because it looks like it hits at an integer doesn't mean it does. If you don't know if it hits at an exact integer or not, go to the table. Remember that when the y coordinate is 0, that's where the graph hits the x-axis. You'll find in the table that y is never 0. Now on your own, I want you to find the real solutions of x cubed plus x squared equals x minus 1. In problem 4, Stacy, Una, and Amir are close friends. Stacy is 1 year younger than Una. Amir is 2 years older than Una. If the product of their ages is 2,300 more than the sum of their ages, how old is each person? We have to start by defining one of the 3 people to be x. And we're going to make Una x. The reason we're going to make Una x is because Stacy and Amir's sentences were in relation to Una's age. So if I make Una x, then Stacy has to be 1 year younger. That's x minus 1. And Amir has to be 2 years older. That's x plus 2. So now that I have an expression for all 3 of their ages, now I need to go to the next part that says if the product of their ages. So if I multiply their ages, the word is means equals 2,300 more than the sum of their ages. So x plus x minus 1 plus x plus 2. How old is each person? Well, now here is my equation. On the right hand, now there are a couple ways of doing this. You could multiply this all out like the book does it, but you don't have to. One of the ways you can do it is just worry about simplifying this side of the equation. There are 3 x's, and 2300 minus 1 plus 2 is 2301. Instead of multiplying this out and worrying if you did it correctly, what you can do is just type into the calculator this expression. Because as long as I make the equation equal to 0, then the solution must be where it hits the x-axis. And you don't have to worry about multiplying it out because the calculator basically does it for you. However, if you want to do it like the book does and multiply it all out, that's fine. But I'm not going to. I'm going to type it in like this. Since I have an old operating system, you can actually see everything I typed in. On the new operating system, it writes the rest of the equation over here. And what you can't see under the cursor is that there's an x there. Then I'm going to hit graph, and you're going to notice there's no graph. It doesn't mean there's no graph. Sometimes students think that when they hit graph and they don't see something, that something went wrong. It could just mean that the graph is not on the screen. So what I'd like you to do is instead to go to the table. Since this is a problem about ages, if you go to the table, I will remind you of a couple things. One of them being that the age of Una has to be an integer. So we don't have to worry about the answer ever being a decimal. And the other thing is that the answer has to be above 0 because you can't have a negative age. So go to the table screen and then keep going down until you find where this coordinate is 0. You should find it when x is 13. That means that Una is 13. Stacy was 1 year younger, so Stacy must be 12. And Amir was 2 years older, so Amir must be 15. On your own, I would like you to try to find what are 3 consecutive integers whose product is 480 more than their sum. I'm even going to help you out. Consecutive integers means one right after the other. So 1, 2, and 3 are consecutive integers. 10, 11, 12 are consecutive integers. But when we don't actually know the integers, the way we write them is x, x plus 1, and x plus 2. Those are the expressions for our 3 consecutive integers.